aspects of mathematics. But it looks a bit simple, isn't it? There's a trick, okay? There is. So let's just look at this and analyze it. 7x minus 1 all over bracket open 3x minus 1 bracket close bracket open again 2x plus 3 bracket close. We are asked to solve it. So what are we going to do to make sure that this simple equation is simplified? Very simple. What we need to do is to fractionalize it partially. Don't mind my word. Solution. So we need to do something here. 7x minus 1, that is this, okay? All over bracket open 3x minus 1 bracket close, bracket open again 2x plus 3. 2x plus 3. How do we fractionalize this? Partially. Very simple. We need to use terms that will make sense to us. We call this A1 all over one of the denominators, okay? Okay? We assign A1 to one of the words. Or rather, we fractionalize using A1 with one of the denominators, and that is 3x minus 1 plus, we fractionalize again partially using another letter, A2, with 2x plus 3, so we call this A2 all over 2x plus 3, okay? If you like, you can put the denominators in brackets. Doesn't change anything. So far you know what you are doing. Alright, so we have done the first thing. The next step is for us to normalize both sides. We must normalize both sides so that we can only have numerators all through and then find the values of A1 and A2 by coefficient method or comparing coefficients. That is it. So let's go. Let's do that right away. We're going to need enough space, so we begin with 3x. This is 3x bracket open 3x minus 1 bracket close once again bracket open 2x plus 3 bracket close before we then have 7x minus 1 all over whatever we have here as the denominator, okay? And we have bracket open 3x minus 1 bracket close, bracket open again 2x plus 3 bracket close, okay? Good. We are going to do the same thing here. Yes, we are going to do the same thing there. So we move on without wasting time. So we have for A1, we have bracket open 3x minus 1 bracket close, 2x plus 3 bracket close, and then A1 all over. The same thing again, we have, you see, we need to do the same thing here. We have 3x minus 1 bracket open, 2x plus 3, all that. We have fractionalized A1. Can you see it now? We move again, that's partially. For A2 plus everything for A2. So we have bracket open, 3x minus 1 bracket close and open again 2x plus 3. Alright, that's for this. Bracket close, this becomes A2 all over bracket open. Alright, are we still there? Okay, we shouldn't repeat this. Yes, we shouldn't repeat this. So let's finish with this. This is 2x plus 3. Alright, we should just write only one at this point. That is going to be bracket open 3x minus 1 bracket close. And that's for A1. If we have done this, we have made a very big progress in resolving this partially. So let's go. This will take care of this. Take notes. This will take care of that. And we are done with this. We are left with only 7x minus 1. Take notes. Good. So we go to this point. This, we vanish with this. Okay? We are left with this 2x plus 3 and A1. Okay? Don't make mistake. Don't make mistake. Then plus, look at this. This is similar to this. So this, we vanish with this, and we're left with just this and A2. That's all. So let's bring out what we are left with. We're left with 7x minus 1. So let's begin. 7x minus 1. That's the first thing here, right? It's equivalent to what? 2x plus 3, A1. Equivalent to, bracket open, 2x plus 3, and then we have A1. That's what we're left with here. Okay? Plus. Look at our big plus. Sounds interesting, isn't it? So we're left with on the 3x minus 1, A2. Big plus, bracket open, 3x minus 1, and then A2. Good. Where's my chalk? A2. Okay? Let me get more chalk. Of course, we have time. Okay, so that is it. So this is A2. So to say, we are done with this. Can you see now, if you have paid attention to what I said earlier, you can see we only have numerators, no longer denominators. No longer. We don't have denominators anymore. We are only left with just numerators all through. And that means we have done well in our partially fractionalizing this equation, okay? Now let's go on. So what do? We clear brackets. We clear brackets and equate where necessary. Find the values of A1 and A2. Let's go. So we have 7x minus 1 is equal to or equivalent to, let's clear this bracket. We have here 2x A1. When this multiplies this, gives you this, multiplies this, is going to be plus, watch out, plus 3A1. That's all. We are done. Watch what will happen here. Our big plus comes in. That's our big plus. A2 multiplies this, is going to be 3x A2 plus, okay, not plus, this is minus, okay? A2 multiply 1 is going to be minus A2. I don't want it to spread into this, okay? So look at what we start. This is the point where we are. Okay, with this we are going to collect like terms. Yes, we're going to collect like terms and equate or compare wisely. So let's go. We have this, and that means we have 7x, all right, minus 1, equivalent to, let's collect like terms. This, 2x A1, and then x is here, plus 3x A2 can come together because of the presence of x, all right? So minus A2, and this can come together. So we have, without wasting time, we have 3A1 can come, we then go with minus A2. That is it. We have successfully collected together like terms in the expression we have. Remember, what we are solving is partial fraction. And that is why we are having this method. There is also another method that is simpler than this, but let's learn this because of the stepwise approach. Now, so let's go on. Let's go on. Something is very, very important here. We maintain 7x minus 1 equivalent to, let's see, we can, something is common here. A1, A2, something is common, and that is what? X. So we have 2A1 is going to be inside the brackets, okay? Also, 3 plus 3A2 going to be inside. What will be outside is X. Good. What next? We look at this. Look at this. Put our big plus sign. Something is here, right? We don't have any much problem here, so we have just 3A1 minus A2. Good. So we have collected like terms. We have simplified further, and we got this. And what happens here? We are going to equate, or rather compare, coefficients of both sides. Yes, we're going to check the coefficients and equate them. So this, there is x here, there is x here. So this first expression will be compared with what? 7x. That's it. So let's do that quickly. We have 2a1 plus 3a2, okay? And then we have what again? Bracket close and open. X is equal to 7x. Can you see? We are comparing them now. Coefficients wisely. So it means that x here, we cancel this x, and we are now left with just 2a1 plus 3a2, all equal to 7. Okay, all equal to 7. We can call this equation number 1. Good. Interesting. So we can call this equation number 1. Can you see? All this long work, equation number 1. We go again. From here, we have just, look at this. We've not touched this. Look at this. 3a1 minus a2. That's this, call this constant terms. Yes, call this expression constant terms. Therefore, we are going to compare constant terms with a constant term over there, and that is minus 1. So let's go. We have, look at this, we have 3a, what is there? 3a1 minus a2, all equal to minus 1. We are comparing, we're equating to this. Okay? Yes, that is it. We now have equation number 2. Equation number 2. Good. We can then solve simultaneously. We can solve this equation simultaneously. And let's go. The first one, look at this one. The first one is 3a1, right? Plus 3a2, all equal to 7. The second one is 3a1 minus a2, all equals to minus 1. This is interesting, isn't it? Let's see. Check. Just watch it. Just watch it. Step by step. Step by step. All through. But if there is any step that you are not clear, that you don't understand, that is not clear to you, please put it in the comment section, okay? Put it in the comment section. I will address it. Very clear. So let's move on. But don't forget, share this with your student who is preparing for any exam. Share with your network. Give me some thumbs up. A like, that is it. Patronize this. Belong to this family. All right, thank you for that. Now let's go. We can now simplify further. Look at this. This is equation number 1, equation number 2. What do we do? That's the question. What do we do at this point? We can now solve using simultaneous equation or simultaneous method because we have 3 equations. One must go. One must go, yes. What do we have there? This is 2. Sorry, this is 2, not 3. Okay, this is 2. Thank God. Okay, I'm happy to see it earlier. Okay, this is 2, not 3. Corrected. So we can now solve. What do we do to solve this simultaneously? Very simple. Look at this. Decide which letter you want to eliminate. So I've decided I want to eliminate A1 so that I can find A2. After which I'll come back and then find what? A1 by eliminating A2. Take it again. I want to find A2. And for me to find A2, I mean the value of A2, I have to eliminate A1. Once I eliminate A1, that is called the elimination method when solving using simultaneous method or simultaneous equation. So if I eliminate A1, I'll be able to find A2. If I want to find A1, I have to eliminate A2 to be able to find A1. That is elimination method in simultaneous equation, in solving simultaneous equation. So let's proceed. So what do we do? Look at this. It's very clear. Very, very clear. Look at it very well. The coefficient of A1 here is 2. The coefficient of A1 here is 3. So we interchange. 3 comes up here to multiply everything. 2 comes down here to multiply everything. Very simple. So if that happens, we have 2 times this is going to be 6a1 plus 9a2 all 21, because this times this is this, okay? This times this is this. This times this is going to give us 9a2. And then 3 times 7 is going to give 21. We do the same thing here. Look at this. This times this is going to give us 6 again, a1. This 2 times minus this is going to give minus 2a2. And finally, 2 times minus 1 is going to be minus 2. Alright, we are moving on. Yes, we're moving on. So what do? Elimination method. We now apply elimination method to be able to remove a1 and then find the value of a2. That is it. That elimination method is indicated by this minus sign. You can see this bold minus sign. Elimination method. It comes here, normalizes this becomes 0. We are left with 0 there. And then it comes here, changes this to plus. Okay? This elimination method comes here, or elimination operator comes here, changes this sign to plus. It becomes 9a2 plus 2a2. And it becomes 11a2. What happens here is very simple. The elimination operator minus goes again, changes this to what? Plus. It becomes 21 plus 2, and this gives us 23. Therefore, a2 is equal to 23 all over 11 by the time we divide both sides using 11. If you divide both sides, that means here is 11, there is 11. What remains is a2 is equal to 23 over 11. So we have found what? a2. That is it. Very clear. Very, very clear. Where is my duster? Very, very clear. Understand that? So we have this. a2 has been found. a2 has been found. So what do we do next? We need to find a1 because we eliminated it at this point. Let's reintroduce a1 and eliminate a2. I love this. We need to eliminate a2 to be able to find the value of a1. That is it. So let's go. We're going to do that here, okay? Can I touch this part? Let me come this point. Okay? Yes, I can still touch this part. So, yes. Let's take away this part because we are through in this part. Let's see how that happens. Okay? How we are going to eliminate a what? A2 to be able to find the value of a1. Yes. We have successfully found the value of a2. Okay? Now let's find the value of a1 because it was removed. It was eliminated in the first place. We are now reintroducing it by finding its value and eliminating a2. So let's go. What do? We restate the equation once again. We have 2a1 plus 3a2 all equal to 7. And then we have 3a1 plus, sorry, this is minus a2 all equals to minus 1. So what do? We are looking forward for this. That is it. We are looking forward. The value of a1. We want to eliminate a2. Very simple. So what do we do here? This is the coefficient here is 1. Coefficient there is what? 3. So we interchange as usual. We interchange. Let me remove. Okay. We interchange. So interchanging is going to give 1 times 2a1 plus 3 a2 all equals to 7. And then we have here is going to be 3 times, we exchange the coefficient of a2, and this becomes 3 times what? 3 here, a1 minus 3 again. Okay, we just write A2 all equals to minus 1. So let's see what we're going to have. Let's see what we are going to have at this point. This is going to be A2, A1 remain. Nothing changes here. 3, A2 remains. And then 7 remains. Good. So look at this. This becomes 9, A1. Good. Here we have what? 3. Yes. Minus 3, A2 all equals to minus 1. Can you see now? Of course, it becomes obvious that A2 is going. It's completely leaving. At this point, it's completely leaving. So let's see. What do we do? It's going to be very nice. So let's see at this point. We are removing A2 to retain A1. Yes. Yes. Okay. Okay. So we go. Look at this. We go here, we have 2A1. That is for this. Okay? And for this, we have plus 3A2 all equal to 7. Good. And there we have 9A1 minus what? 3. This is 3. A2 equals to minus 1. So we eliminate quickly. Let's eliminate. We apply elimination method or elimination operator. Okay? This 2A minus will give us minus. Look at this. Minus. Oh yeah, of course, it's going to be minus. Minus 7A1. Let's see how it goes. I hope we're not making any mistake here. We're not making any mistake. Let's see. Okay. Let's see if there's any mistakes anywhere. This is minus. Elimination method here. Of course, it's minus. Okay. Alright, if we say minus here, it's going to be minus here, right? Good. It's going to be minus there. You see, I'm trying to find out if there's any problem anywhere. So it means we have minus here. We have minus here, yes. It's going to be minus there, yes. And this changes to what? This changes to minus. Good. This is interesting. Can you see I'm finding out? This, we multiply this, and that is okay. And finally, this is going to be minus as well. Minus 7 here. Because everything will change. So let's see. So minus to A minus, this becomes 11. Okay, minus to A minus becomes minus 11A1. Good. Very interesting. So sign would have landed us to a wrong answer. But thank God I was able to find out something was missing somewhere. So you have to be smart. When manipulating figures, you have to be very, very smart. Good, so we move on. Minus 3A. Okay, this minus is going to nullify. This becomes plus. It vanishes, so we have just 0 here. And this minus, can you see? Minus, this is interesting. Can you see that? Something is missing again. Look at this. This 3 multiplies this to give us 9. Multiplies that, and we fell at this point. Can you see? So it should have been 3. It should have been 3 at this point. Yes. Multiplies this, we have this. Multiplies that, we have that. It multiplies this, minus 3. Should have been here. Good, because we are operating with plus. So let's check. This should be this. Alright. Check. So minus 7, minus, this will change this to plus. It becomes what? 4. That is it. Minus 4. Oh my goodness. And then we have now minus 11A1 all over minus 11, of course. Everything is cancelling out at this point. Is equal to minus 4 all over minus 11 again. So what happens here? This will take care of this. And finally, this will cancel this. A1 is equal to 4 all over 11. Solved. We have found the values of A2 and A1 respectively. Alright? The final summary, we are going to summarize. We are going to summarize smartly. And look at this. The summary is going to be something interesting because that shows we have solved that equation by applying partial fraction method, okay? Comparing the coefficients of both sides, and we have successfully found that 7x minus 1 all over bracket open, 3x minus 1 bracket close and open again, 2x plus 3 bracket close is equal to, hold on, is equal to a1 all over 3x minus 1 plus a2 all over. What happens there? 2x plus 3, okay? And finally, we go on again, 7x minus 1 all over bracket open 3x minus 1 bracket close is 2x plus 3 bracket close, all equivalents. Hold on. Okay? Look at that. Just watch this. For A1, we have 4 over 11. And that is going to be, for A1 is 4 all over 11, right? Over 3x minus 1. Good. So we put our plus sign. For A2, you remember the value we had for A2, and that is 23 over 11. So we have 23 all over 11 for A2. Then we have what? 2x plus 3. Solved. It's been solved. The values of A1 and A2 have been found to be 4 over 11 and 23 over 11. That's it. Alright, I'm going to sign out at this moment. Oh, hold on. If any of these steps are not clear, come on, put it in the comment section.